Introducing the Ravine Lateral Access System featuring the Cascadia Lateral Interbody System from K2M, Complex Spine Innovations. The Ravine Lateral Access System is an innovative patient-based, minimally invasive retractor, providing adaptability to both patient anatomy and surgeon technique. With its dual flat blade design, the Ravine retractor provides a true muscle-splitting trans-psoas approach and offers direct visualization to the disc space. The Ravine Lateral Access System includes a wide range of versatile instruments, as well as a reusable bifurcated lighting system. The Ravine Lateral Access System is designed to work in conjunction with the Cascadia Lateral Interbody. K2M is the first leading spine company to offer a 3D printed titanium interbody designed to allow the potential for direct bony on-growth and ingrowth. Cascadia Lateral is a titanium implant featuring lamellar 3D titanium technology. The 70% porous design allows for an enhanced radiolucency compared to solid titanium designs. The Ravine Lateral Access System, in conjunction with the Cascadia Lateral Interbody, provides a full line of versatile instruments and implants designed to provide true muscle-splitting trans-psoas patient-based access to the spine, and an interbody designed to specifically support potential bone integration and fusion. The patient is placed in the lateral decubitus position with the iliac crest directly over the table break. Tape is placed on the following regions to secure positioning: just below the iliac crest, over the thoracic region, from the iliac crest across the knee to the table, from the table to the knee, over the ankle, and to the table. Care should be taken to prevent any undue pressure points. Next, fluoroscopy is used to identify the correct operative level, and a skin incision is made targeting the middle of the disc. Finger palpation of the psoas muscle or the anterior tip of the transverse process is used to confirm the proper location. Once verified, the initial 6 mm dissector is introduced into the prepared path and advanced through the psoas muscle, and the dissector is docked directly onto the middle of the disc. Next, the intradiscal guide wire is placed through the 6 mm dissector and advanced into the disc. To achieve greater soft tissue dilation, the initial dissector is removed, leaving the guide wire in place. Then the larger dissectors, 14 and 24 mm, are introduced over the guide wire and advanced into the pathway already safely established, keeping in line with the muscle fibers of the psoas and safely anterior to the lumbar plexus. The largest dissector should match the width of the Ravine Lateral Access retractor blade. Blade length is determined by any one of the dissectors in relation to the skin level. Once the Ravine Lateral Access retractor is assembled with the appropriate sized blades, the dissector is removed. The retractor is introduced into the same safe corridor by capturing the guide wire in one of the 6 desired blade channels. The Ravine Lateral Access retractor is then rotated 90 degrees so the orientation of the blades is in line with the end plates. Once lined up appropriately with the end plates, the frame is retracted open so the free blade, the one not capturing the guide wire, is directly over the adjacent vertebral body. The corresponding fixation pin is introduced into one of the blade channels and is advanced into the vertebral body using the provided driver. Next, the guide wire is removed and the retractor frame is further retracted open until adequate access and visualization of the disc is attained. Additional fixation pins may be used at the surgeon's discretion, and a reusable bifurcated light source can be utilized through the channels. If more soft tissue retraction is desired, blades for both the anterior and posterior aspect of the frame are provided. The corresponding AP blade is introduced into the incision, drawn back along the frame's AP adapter, and locked into place. If the optimal AP blade length falls between the lengths available, an AP blade extender can be inserted down the channel of the blade using the intradiscal shim inserter. The AP blade extender allows for lengthening in 2 mm increments. Trials are available in parallel, 8, 12, and 15 degrees lordosis, and are 1 mm undersized in height to allow for a slight press fit of the implant. The 60 mm length trials are used to measure if a 45, 50, 55, or 60 mm Cascadia implant is needed. When looking at a true AP fluoroscopy image, the distance from the ipsilateral end of the trial body to the beginning of the bulleted tip measures 60 mm. The distance from the AP cannulation to the beginning of the bulleted tip measures 55 mm. The distance from the beginning of the ipsilateral side of the first trial AP cavity to the beginning of the bulleted tip is 50 mm. If correct placement of the trial reads any distance shorter than that, a 45mm implant should be used. The Cascadia Lateral Interbody System features lamellar 3D titanium technology and is approximately 70% porous. Its 500-micron pore diameter and 3 to 5 micron surface roughness are designed to promote cellular activity and potential bone integration, while allowing for increased radiolucency compared to its solid titanium equivalent. The internal reverse hourglass implant design allows for increased end plate contact compared to an elution peak interbody without sacrificing internal bone graft volume. Cascadia Lateral is offered in 22mm widths, parallel, 8, 12, and 15-degree lordosis, with heights ranging from 8 to 16 mm and lengths from 45 to 60 mm. For implant insertion, assemble the inner shaft and inserter handle, and then thread the appropriately sized implant onto the end. Graft containment slides are provided to help contain the graft material held by the implant, as well as to protect the end plates if so desired. The bulleted tip of the Cascadia Lateral implant should extend past the contralateral side, just 3 mm beyond the edge of the end plates. This ensures that the implant has maximum contact with the end plates. Once satisfied with the implant's positioning, AP blade and fixation pins are taken out prior to closing the frame and removing the Ravine lateral access retractor. In instances where removal of the Cascadia lateral interbody is deemed necessary, the inserter may be threaded back onto the implant, and a slap hammer may be used to facilitate removal of the interbody space. The Ravine Lateral Access System, featuring the Cascadia Lateral Interbody System from K2M, Complex Spine Innovations.